Hey, my name is Daniel Allen. This is Lab 1 for the half adder, incrementer, full adder, and 4-bit adder. So, I'm going to real quickly go through these digital circuits. The half adder is very simple, right? So, you've got the XOR circuit, which is only on when one of the uh, one of the inputs is on. If both of the inputs are on, the sum is off, and the carry is on. The incrementer is probably the most important one to show here, that and the 4-bit adder. But the incrementer, right? So, so you've got 1, right? It's going to go into here, into A. It's going to come out the sum, right? So it's basically the same exact thing happening in this half adder, right? Because that's what it's using. If I add the incrementer, though, that's going to go into B, which is then going to add or go into the carry, which is then going to make the output 2. And then I can keep incrementing A, and it'll just do that same thing with these half adders over and over and over until we finally get to this, which carries, because that's the maximum value that you can have here. Now, the 4-bit adder just uses these full adders, which basically just does the same exact thing as this half adder. Right, it's got the 3 inputs for the XOR instead of only 2. And in the 4-bit adder, it's going to do the same thing. So, right, you've got the carry in. You got, right, so carry in just goes into the carry in, which then goes into the sum. But if I add this, then it goes into the carry out, which goes into the carry in of this, which adds 1 to that. And then I can add 1 to B, and then it's gonna make the sum, right, because it's activating all 3 of the XOR circuits, and then that's gonna add 2 to that. And then you start getting, like, we'll go to one of my test cases that I have in here in my template. So let's say we do all right, so let's say we've got no carry in, we've got 7 and 1. So should probably do it like this. So 7 in A, 1 in B, right? So that overflows this because 7 is the maximum, so it overflows that. And so we've got signed overflow with carry out being 0, overflow being 1. If we do 8 and 8, we now have carry out and overflow with a 0 output value. So yeah, that's the 4-bit adder. I'm going to show these in GTK Wave now. I don't know if I have to show all of these, but I mean this one's very simple. Like, it's so simple. So it's just, right, A is on, sum is, or B is on, sum is on. A is on, sum is on. When A and B are on, sum is off, carries on. I'm just gonna go to the incrementer, and we will do A, do carry, increment Y, right? So when we're at 0 A and increment, or right, the incrementer at 1, then we've got output Y value of 1. A is 1, incrementer is 1, right? So it's just incrementing by 1 each time. And 2 and 1 is 3, 3 and 1 is 4, and so on. Until we finally get over to here, which is F and 1, which carries, gives us an output value of 0. We are going to go to the 4-bit adder now. So this one, we're going to get these values. So everything's 0, output is 0, right? Just like just like we showed down here. So in this scenario, 1 and 1 with the sin of 0, it's going to give us an output of 2, right? Because it's just adding 1 and 1. In here, it's only got, I don't know if I can, I wish I could like change the value of cn, but I'm not entirely sure how to do that in here. So I'm not really going to worry about that, but this is just like, it's just doing very simple addition. So it's just 2 and 2 is 4, 3 and 3 is 6. And then we get to the point, right, where that would carry out. Right, if we did 4 and 4, that's going to overflow. So we just go back to 0. And I have all of these like tests that I did, which are just tests to see if like everything works in this 4-bit adder. So I'll do one more of these. So I mean, different signs. So we like this one is if we put 7 in B, and like there's no -8 in decimal, but you do, right? That's -1, 2, 3, 4, 5, 6, 7, 8. It's just back to 8, right? So that's just going to be F. Output's going to be F. Mixed signs, right, is just if we did 3 in A and if we did C in B, it's going to equal F as well. It's the same thing. And yeah, both of those give no overflow, no carry out. F and 1, so F and 1, right? So F is like the highest value that you can go. So if you add 1 to that, right, it's just going to carry out. There's going to be no overflow, and the output's going to be 0, just like I have listed here. So this is, yeah, it's the same as doing -1 + 1. So yeah, I mean that's pretty much it. Like, I guess the other important thing to maybe go over is like how these buses work. So the input, right, if the input here for A is, I could have shown it here as well, but if the input here is 1, right, it's going to be, the output is going to be 0, 0, 0, 1, which is binary for 1. And it's just very simply going to do that all the way to the very end through these half adders. So, right, like 1, 0, 0, 1 is binary for 9. 1, 0, 0, 0, binary for 8. So that is, I think, everything that I wanted to talk about.